So my name is Johan van Amersfoort. I work at ITQ. I'm a huge nerd. I love to talk about technology. I love to tinker, do stuff in my lab, but also work with customers and see how we could get the best out of the solutions they buy or consume nowadays. I'm also a host of a couple of podcasts. For the Dutch people in the audience, they probably know the left one. For the non-Dutch speakers, I'm part of a podcasting crew together with Frank Denneman, who was here last year, and Duncan Epping. We create a podcast called the Unexplored Territory podcast, and we talk about everything VMware. If you haven't listened to it yet, it's a bi-weekly show, and it's really awesome to create. I also wrote a couple of books. The left one you can download for free. I'll share the link later on. And in the books, I basically talk about this. Like, what's the best way to design and build a VDI platform for any type of solution? Could be simple applications, but also complex applications. Now, I don't really have an agenda, but we're going to talk about three things today: hardware, APIs and codecs, and software. That's basically it. And let's start with the hardware. Who recognizes this GPU? So which is it? Yes, but which one? It could be like either 1, 2, or 3. So just pick. 1. Yeah, it's a Voodoo 1. Technically, it's not a GPU. It's an accelerator. But it was the actual first card that showed us what the potential of a specific accelerator was. Specifically in combination with an API. You need an API to make a card work, or drivers, if, for that matter. And with that API, you could basically turn this game, which is it? Yes, which one? No, 2. Almost there. Yeah. 50-50 chance. Right, so this is unaccelerated. This is accelerated. It's hard to see with all the lighting, but you can see here basically the textures are a bit more smooth. And this is based on technology we had in the late 90s. Now what happens if you use a different API, a ray tracing API? You end up with the same game, same binaries, everything the same, but using a different API, you get a different user experience. And I'll show this in a couple of demos. So, do you need a GPU? Yes, short answer. And the main question we get when we work with customers and they have like a question, why do I need a GPU? Well, it's not just for graphical purposes. So this is a simple Windows 10 desktop running a NVIDIA GPU. And there's a tool called NVIDIA SMI. If I open that up, does this work? Yes, it does work. There's a list of processes that are currently using the GPU. And what you can see in the tab called Type is it says C plus G. And quite interesting is that there's for instance, a utility called searchapp.exe. This is the actual search function in Windows 10 and Windows 11, etc. What this says is that the searchapp.exe is using the GPU to do a lot of indexing. So Windows is expecting a GPU for some of the processes it's running inside the operating system. And with Windows 11, that's even more. So it utilizes the GPU to offload certain tasks, so the CPU could be used for different things. So it's expecting a GPU for, mainstream things. So what is a GPU? And I'm not gonna do a 30-minute GPU deep dive, but I do want to cover some things that make sense later on in the session. So this was the actual first GPU. Who recognizes this one? No one? It's from Diamond. Well, it is not the first one, but this is the, I think, the Riva TNT, Riva 128. So this was actually one of the first GPUs used for gaming. And it had 16 MB of RAM and 2 cores, 2 whole cores. 100 megahertz, no encoder. And if you look at how a GPU relates, or how you compare it to a CPU has multiple complex cores, and a GPU had thousands of cores that are less complex, do a lot of parallel processing, but of specific types of calculations only. Nowadays, a GPU has different types of cores, and we call this a compute engine. So it has compute cores, it has tensor cores for specific deep learning related workloads, and it has ray tracing cores. And I'll show those ray tracing cores in one of the demos later. Next to the compute engine, it also has memory. We call that frame buffer. And it's quite often, well, not quite often, it's always a lot faster than RAM inside your PC. So in this case, DDR6 is mainstream. We can put multiple of these GPUs onto a single card. And in nowadays is most common offering for VDI, an NVIDIA A16. We have 4 of those chiplets, those 4 of these GPUs with those with that memory on a single card. But there's one thing missing here, and I'll jump into that later on. We need APIs to make that card work, and I showed that in the combination with Glide 3D with the Monster card. But in this case, the most commonly used APIs are for graphical purposes, OpenGL, Direct3D, and quite often used in game and Falcon. And computational APIs are CUDA, which is by far the most commonly used one for computational workloads. Things like deep learning, machine learning use CUDA. And OpenCL's, is less known, less used. And one API is specifically tied to Intel-related hardware. Who remembers this thing? Julien? Just Julien? Yeah? Well, there was one thing missing on the GPU, which I mentioned, and that's what we call a media engine, containing encoders and decoders. And these are really important when you look at user experience. Because we have those graphic APIs and the compute APIs that basically talk to the compute hardware and the RAM, but we need codecs to talk to those media engines as well. And the most commonly used codecs within VDI are H.264 and H.265 or HEVC. Those are the same. And the new one is AV1. Now, if you look at these codecs, there were a couple of those missing, which are BLAST and PNG. The reason why they are missing is that they don't talk to hardware. So they're software-based codecs, and you use those codecs in, well, mostly Office-related workloads. But H.264 can potentially run on hardware, so could potentially use the GPUs. And H.265, and I see I need to adjust the color of the last bullet. H.265 and AV1 do use hardware. It's mandatory if you want to use those codecs to run that on hardware as well. Right. In order to use all of this, you need a virtual machine. And within the virtual machine, you have specific graphical apps, graphical functions within apps. Take an EMR application, if that has, for instance, a Google Apps plugin that uses graphical functions, then that's a specific function within an app that's not graphical. And they're within, for instance, Windows 11 or Windows 10 or some Linux distros, you have specific functions within the OS that use a GPU as well. Now, from a computational perspective, same thing. You have compute apps. You have specific functions within an app that use a GPU for computational workloads. And you have specific OS functions like the indexing service that I just showed. And then we have Blast Extreme, Zoom or Teams, and things like YouTube that also benefit from a GPU, but looking at the codecs in that case. So how do you assign, or how do you, basically assign such a GPU to a virtual machine? And we're going to look at the different options. So the first one, that has been here for ages is direct pass-through. You basically have a single GPU, you assign it to a virtual machine, and that's it. You can use it. Then there was vGPU that was introduced, so you basically have the same virtual machines, but you put a GPU scheduler in the middle, and now suddenly multiple of those virtual machines can use the card. And their scheduling will take care of assigning the right workloads to the right VM. Then there was SR-IOV, which is basically assigning a virtual function to a virtual machine. And besides AMD, Intel is using that as well. And then finally, and this is relatively new and not really commonly used, besides, well, the only use case currently using this is computational related workloads, so deep learning, for instance, which uses SR-IOV in combination with vGPU. Not really important right now, but it's good for you to know that Intel is diving into this space using virtual functions, and vGPU is still being the main scheduling or the main kind of virtualization platform for NVIDIA GPUs. So we have different types of remoting protocols using that. So I already mentioned Blast Stream, but we also have PC over IP and RDP, which are not owned by VMware and are also not maintained by VMware. And there's CloudXR, which is a relatively new player within Horizon. So who has seen CloudXR? Sort of. This is made by NVIDIA, specifically built for VR workloads. So it has some really awesome capabilities, but yeah, specifically for VR. So let's dive into Blast Extreme. Like I mentioned, it's owned by VMware, which also means that VMware could put innovations into the connection protocol without working together with other vendors, like Technologist, for instance, who owns PC over IP. It's based on VNC, which is a commonly used platform to do remoting. It supports all major codecs. And, which is really important, it's tolerant to latency. And I'll show a little bit later in some of the demos how to adjust it for latency intolerant use cases, or latency depending use cases. So it supports high fidelity use cases, which is really awesome, and I'll show those in a bit. And of course, highly customizable. Now, what can you optimize? First of all, quality, which is important for some use cases. Gaming, for instance, and it might sound like not really suitable for customers, but we did implement certain gaming use cases at customers. One of our biggest reference customers in that case is Topgolf in the US. So they built a game called Top Tracer, where you have who's been to a Topgolf location before? Okay, so you basically play golf. You have a kind of a driving range in front of you. There's a screen in front of you, and you basically hit the ball. And what happens when you hit the ball is that you have an augmented overlay of Angry Birds, and the ball could hit a bird. And the whole thing is offloaded into Horizon. So they use Horizon to actually show that, which is really awesome. So the data center is somewhere located in the US, and all the individual locations of Topgolf stream the game from that central location. So quality in that case is also important. Compression is important, especially if you are maybe working from high latency environments. Bitrate is important, and I'll explain in a bit why. The same with frame rate. We can optimize the latency tolerance and channel usage, and I'll cover that in a bit as well. Let's dive into the quality and the compression first. So VNC uses a technology called quantization. And quantization basically says the higher the quantization, the higher the compression, the lower the quality, but the better the latency tolerance. So take a, how do you call it? Like, I don't know, data. And if you scale down the quality, you basically get a lower bit rate, which improves the all-over frame rate. And I'll show that in a demo. You basically with adjusting the whole quantization parameters, you basically get a sweet spot that's ideal for the situation. And you can do that using a min QP and a max QP. We always start with a starting point of a min QP of 10, and I'll explain in a bit why, and a max QP of 26. The 10 is basically the highest quality. It's the lowest number, but it's the highest quality. And the max QP, you can adjust it until 51, which means that you add a shit ton of compression, but as a result, in case of latency increasing, the user experience will be good, will be continuous. Now, frame size in this case is important, and this is one of the biggest misconceptions we see at customers. Like, yeah, well, we have a 4K screen, and we want to have great quality and a remoted session on 4K. But they forget that 4K is 4 times a full HD screen, and especially when you don't compress that individual frames, every single frame that's sent over to the endpoint could be 20 MB. Now, what happens if you send 60 of those frames per second over the network to an endpoint where there may be a WAN connection, multiple firewalls, all sorts of hops? Your latency will increase. So that's definitely something you want to be aware of. So limit the frames per second to what you need, not what you can what you can do basically. So 60 frames per second sounds really awesome, but the YouTube video on average is not exceeding 30 frames per second anyways. And the human eye is hardly able to distinct 25 from 30 frames per second, for instance. Also, if you take someone that does Office all day, just typing into Word, and you see the cursor popping up and popping, they probably use like, I don't know, 5-6 frames a second. So don't give them those 30 frames because they don't see the difference anyways. So this is really important. And these QP values can only be adjusted for those 3 different codecs. Okay, so we had the codecs, use cases. So BLAST and PNG are specifically built for Office-related use cases. So use cases that don't have a lot of changes, don't require high quality, and they're fine. But if you have that quality demand, if you have specific applications that need to run that, switch over to H.264 or H.265. So 264 has that high quality, high FPS app requirement. So modeling of something like an airplane or something else, you're building a design. If you have that requirement for a high fidelity frame rate, then that could be a choice. And if you need not just that, but also increased, well, let's say an uncompressed view of what's happening in the virtual desktop, then H.265 and HEVC might be a great option, but they do require hardware to decode the frames as well. That's really important, especially AV1, which is only supported in specific types of workloads. Now, how do you configure a codec? Well, it's fairly simple. You open up the Horizon client and just select which codec you want to use. By default, that's the only thing you need to do. So if one of your customers is calling, or you have like a user that calls you, like I have a bad user experience, this should be one of the first things you should check, because you could have GPUs in the backend, but if they have not selected any of the decoding options in the client, they won't use the GPU for encoding and decoding. We're almost there with the demos. So really important, virtual channels. So Blast Extreme support channels between the client and the agent. The most commonly used one is the remote experience channel. This is basically the channel that you use if you are watching like whatever you're doing inside the virtual desktop. But there are more. The USB redirection channel, great, but this is basically Satan within the entire stack. Because if you use this in a bad way, this is going to be awful. Multimedia redirection is a side channel, and you could use it, but we hardly see it at customers. And these are the most commonly used peripherals that use their dedicated channel, like audio or RTAV. So if you have Teams running inside your virtual desktop, you'll use RTAV. The same with clipboard or thin print. If you want to use a printer, you'll use thin print, and clipboard redirection, same thing. This one, so if you don't have a channel you could use, for instance, a webcam channel, no. Let me rephrase that. If you use a webcam through USB redirection, it's going to be uncompressed, sent over USB. And nowadays, modern USB interfaces already support like 10 gigs a second. So what happens if you have a device that supports that 10 gigs and tries to send over 10 gigs of raw data from one end to the other? It's not going to happen. So it definitely impacts the user experience in a bad way. So choose the channels wisely. Like I mentioned, or what I haven't mentioned this, but VVC and the peripheral channels are compressed. MMR is redirected, and USB is uncompressed. This is your very last resort. If you have hardware that required USB redirection, but it isn't part of the peripheral channels, then you could use it. But yeah, it's definitely look at what it does to the rest of the user experience. So, first demo. I'm going to show how to monitor those channels. So what you basically see here is one of my favorite apps I use to test user experience is the WebGL Aquarium. And what you see here is PerfMon. And I added some metrics to PerfMon, like GPU usage, like the encoder usage, decoder usage. But you can also add all individual channels of the Blast Extreme protocol as well. And you can automatically see if I change what I'm doing there from, for instance, a WebGL app to YouTube, that, for instance, the yellow bar is the decoder of the GPU. You see automatically that the decoder stuff of the decoder is already doing stuff. And if we pause the video, you can see that the decoder is automatically dropping. So this is a great tool to see what's actually happening within the virtual desktop. We open up the WebGL app again, decoder is not used anymore. But in this case, the GPU usage increases. Right. So we did some monitoring of the UX. This is one of my favorite tools to do so as well. I just use PerfMon. This is a different tool who recognizes this tool. Remote Desktop Analyzer. There's a free version that lets you view all of this in this tab, and this is the paid version, which costs, I don't know, $20 a year, so it's hardly anything. And you can see basically everything that's required to adjust or to monitor the user experience. And what you can also do is adjust it. So you can select different encoders on the fly. You can adjust the frame rate and even adjust the QP values if necessary. So if you have a bad user experience at this moment because of any reason, you can adjust the QP values to see what the effect would be. So if I would adjust the min QP to 25, for instance, you can immediately see that the compression will kick in, and it'll probably use less bandwidth. Now I'm going to adjust it to 15, and it used on average 8 MB just now, and now it increases to 20 MB. So you see that there's less compression being added to the session, and now it changes compression again. So it fluctuates a little bit between, I don't know, 15 MB, and I just saw it running on 70 MB as well. Right. Next demo, OpenGL. OpenGL has been there for a while now, and we just talked about Quake. What you can see at the top is that it's actually running on an Intel GPU. So that's the Horizon Performance Tracker. And this is running on the Intel Flex 140 GPU. We, together with VMware, we kind of optimized the API to let this game run. You can see that the frame rate is okay-ish. But it's fully running inside the virtual desktop. Now, what happens if we do the same with the ray tracing API? So we tried to do this with the Intel GPU. That doesn't work yet. So Quake 2 has a specific version called Quake 2 RTX, which is this one. And the APIs have been built by NVIDIA. So we try to basically, figure out a way to get the Intel card running on the NVIDIA APIs, but that doesn't work, unfortunately, yet. So same game, same binaries, same everything. The only thing that's different compared to this demo and the previous one is the API it's using. So you can see above that there's a renderer called RTX. And that was OpenGL in the previous demo. Here is the remote desktop analyzer again, and it's set in transparent mode, so you can actually look beyond this, and you can see like the coloring in the gun, for instance, or I don't know if you can see it. Well, here you can see the reflection of the mirror is all dynamically adjusted using ray tracing APIs. Let's run the demo one more time. Yes. There's a specific part of the demo which I think is really awesome and really shows the benefit of the RT cores, so the real-time ray tracing cores, and the API you're using. Let me pause it. So he's looking up. I don't know if you can see it, but there's glares coming above downstairs, and the glares. Oh yeah, it's hard to see on the projector. I can actually see it on the screen here, but the glares are dynamically adjusting, and that's all just due to the fact that you have additional cores that do that, and a specific API that's capable of offloading those calculations to the GPU. Now we have some useful resources if you want to play around with this yourself. First of all, you can download the first book for free on our website. It covers like 70 pages of just stuff around remoting protocols and GPUs. So if you want to know anything about everything there is to know about this, you can download it there for free. And we're working on, not really allowed to say that yet, but we're working on the possibility to download the second book for free as well. Maybe the end of the year somewhere. So there's a second guide, which I really like, which is the Blast Extreme Optimization Guide. This is built by VMware. It's on TechZone, and it covers some more in-depth stuff around the codecs and codec switching is something that's relatively new inside Horizon, and they're constantly updating what's happening there as well. To conclude, well, not really to conclude, but I have a couple of conclusions. First of all, I think Blast Extreme works out of the box really well, but it does require optimization for better quality. So always, depending on the workloads, run those workloads inside a virtual desktop and run either Perfmon or RD Analyzer to see what's happening if you run a certain application, access certain APIs in the application, etc. I think that almost any type of, or maybe any type of high-quality app can run inside a virtual desktop. It's just a matter of troubleshooting, tweaking, tuning, and ensuring that the UX is good. And you should definitely use tools like Perfmon or RD Analyzer to optimize the UX. I have 15 minutes left and would like to open up for questions, but also I have a live environment here, stand by. If all goes well, should have it somewhere. Yes. No. Oh, almost. And there we go. Yeah, this doesn't work. Oh, there we go. Yeah. Right. So I have a live environment here that shows both Perfmon as well as RD Analyzer. So if there is any specific question you might have related to tweaking and tuning the connection protocol, feel free to ask. None? Well, that's easy. Well, let me show you one thing. I think I talked about the compression a bit, and if I just have RD Analyzer there.
Maybe one question.
Yeah, sure.
So we hear often that GPU utilization is way better in bare metal than virtualization. What's your point about that in 2023 with the enhancements that we know that you showed also earlier between NVIDIA and VMware?
Right. So there's two answers to that question. So the question is like, how does virtualization impact GPU usage, I guess, and is there a comparison between bare metal and virtualization? So I had the opportunity to talk to Chris Wolf 2 weeks ago, and we had a conversation around GPU virtualization, and there's hardly any difference in things like latency when it comes to bare metal, if you compare to bare metal virtualization from a computational perspective. So if you take that into account, just computational APIs and how you would be able to run deep learning workloads on vSphere, there's hardly any difference between virtualization and bare metal. Now, if you take a look at virtualization for graphical purposes, it depends. So some applications might work really well virtualized, but there are some workloads that require, for instance, more than 60 frames per second. If you look at VR, virtualizing VR inside a virtual desktop, before Cloud XR was released, that was not possible. So you could only kind of redirect virtualization workloads for VR, bare metal. Cloud XR solved that, but yeah, there are some applications that might require. Well, another great example is X-ray images. So remoting protocols are, well, no, Blast Extreme is not certified, medically certified to show a medical image. So if you want to do that, remote it, you can surely view the image, but there's no certainty that it's one-to-one uncompressed displayed. So those are typical applications that you might not want to virtualize, or virtualize with the risk in mind that it doesn't maybe 100% accurately show what the result is. Looking at like specific apps, I got a demo here of running an F1 simulator, fully virtualized. That runs really well, but it all comes with like, how many resources do I have? How many GPUs do I have? You can imagine that, for instance, an RTX board, like an RTX A6000, is a really powerful board, but it's not as powerful from a gaming perspective as a Titan card or like another high-end gaming card. So it depends on the workload, but on average, I would say that for mainstream workloads, there's hardly any difference. Long answer to a short question.
No,
Is it an answer? Okay. Any other question? Otherwise, I'll hit some compression to the video. Right. So the video is now running on 60 frames a second. You can actually see that it does not output that in real time. Well, great demo. Let me restart RD Analyzer. Oh, bear with me. This is this also always with live demos, right? Sorry? Right, so my start button is gone. Oh, my start menu is behind here. Let me try to fix that. Yes. Well, that looks different. Okay, here's the video. Not really displayed like I wanted it to. And as it looks now, I fully broke my machine. You see, there's no GPU anymore. I should have prayed to the demo gods before I did this. Yeah. Yes, well, this definitely requires a reboot, and we're not going to wait for that. So, are there any final questions? If not, and you might have a question later on. Where's the mouse? Yeah, this works really well. I think I broke literally everything there is to break. Oh, no, there we go. Yeah, so if you have any questions, my email fairly simple, johan@itq.nl, but I'll be here until after our second session about the VCDX program. So I'd be happy to take any questions you have, and I'll try to fix my lab. So if you want to see additional things, then I'm happy to show them at the booth as well. Thanks, and enjoy the rest of the conference.